Alex here is an employee of an amazing firm in which every employee is equally important. The salary of each employee is the data of equal importance. Once Alex and other employees get their salaries, they have different expenditures. He spends 50% of his salary on his children's education, while the rest on electricity, rent, etc. Wow, being independent is hard. Don't you just wish you could depend on your parents forever? Now, if you look at this data, you can see that more importance is given to education than to rent, electricity or food, as it should be. Such data where importance of each observation varies is called weighted data, where the weights reflect the importance of each observation. So, in this case, the simple arithmetic mean, which we previously learned, will not work. What you will need is something called a weighted mean, which is an average where each value has a specific weight assigned to it instead of frequency. Want to know something exciting? The formula for weighted mean is the same as that of simple arithmetic mean. Well, almost the same. Instead of frequency f, we'll have weight w here. And the rest is history. Now that we know that weighted arithmetic mean is when we associate data with certain weights signifying their importance, let's dig a little deeper in this concept by solving this question here on the left. Unlike the firm Alex works for, we can see from the data that this firm assigns different slabs of salary for different number of employees based on their positions probably. These observations have these different weights. Let's get down to business. To find the weighted mean, we'll use this corresponding formula. To figure out the value for summation of Wx, we'll have to draw another column which will include the product of these two. You know what's next. Sum up these two and put them in the formula. And there we have it. We now have the weighted arithmetic mean of our data. As easy as ABC. We're not done yet. Since I'm determined to teach you everything, literally, there's one more concept related to arithmetic mean I'd like you to know about. Moving averages, not literally moving. If we have a certain data like the speeds of a car at different spots, then its moving average will be calculated for a sequence of subset of data instead of the whole data altogether. Also, that sequence or subset may differ from question to question. To understand this better, let's consider this data shown on the right here, for which we have to figure out the 3 days moving average. For our own ease, let's show this data vertically. Much better. Okay, now, we're asked to find the 3 days moving average. I wonder how we'll show this. Yes, in columns. We'll keep on adding 3 successive observations to note the results here. After that, we'll divide the results with 3 to get the average, which will be noted here. Ready, set, let's move. The moving average of first 3 observations will be the sum of these 3, which will be written in front of the middle value 55, leaving the first row blank. Now, divided by 3 and boom! We have our first moving average. Now, I know what you're thinking. Why didn't I consider 24 to be the middle of subset? Well, because there's no values preceding it, silly. Moving on to the next 3 intervals, we'll consider 28 as the center, and for the third set, we'll consider 45 as the center by dropping the first 2 observations. Keep going till you reach the last possible set of 3 observations, for which the middle value will be 54. This row stays blank, of course. You know why. Well, that's it, my friends. Come back for our next video to learn about some more ways you can play around with data.